Starting with version 195, SkyTrack now has the ability to list and view satellite conjunctions. A conjunction does not necessarily mean a collision, but it refers to any event where the orbits of two satellites come within close proximity to each other, and in this case within 5 kilometers of each other. The conjunction data is sourced from Celestrak.org, and it's generated by the SOCRATES Plus system. This data set is updated every 5 hours. It includes all close approaches within 5 kilometers of each other and that are expected within the next 7 days. To access the data, we just click download, and it'll download that conjunction data from Celestrak.org. It'll only download it if it's a new file, so it'll check the timestamp and compare it to the last download and only download if it's new. The file can contain 60,000 or more conjunctions, so SkyTrack has some filters that you can set to improve processing speed if you're only going to be viewing over the next couple hours. So in this case, I have just the list just contains that are conjunctions that occur within the next 4 hours. I'm only interested in ones that are visible at my site. I want to visually view or record the conjunctions, and I'm asking it to exclude any objects that are eclipsed by the Earth's shadow. So here's my list of conjunctions. The two satellites. You'll note that that one of the two will be an active satellite. The Celestrak data doesn't have possible conjunctions, possible collisions between two pieces of orbital debris, so it's only concerned about active satellites in which the orbit can be managed. So it has the time of the closest approach, the separation expressed in kilometers between the two objects at closest approach, and the relative speed relative between the two objects, and the probability of collision, where 1 would mean 100%. It's important to note that in addition to downloading conjunction data, you also should download fresh orbital data, and I recommend using the group of satellites called active satellites. So it's going to be the list of all currently active satellites. It won't have debris in it, just the active satellites, but each conjunction will be one of the objects will be an active satellite. So for instance, when I click on this one here, both objects are found in that orbital data file that we downloaded. So I have RE and DEC coordinates for each, and because I have that, I can also then calculate the angular separation. So how far apart from the viewer location the two satellites come within each other. Note that doesn't necessarily directly correlate with this actual separation expressed in kilometers because of the differing range. So the further out into space the conjunction occurs, the closer it appears from the viewer location. Whereas we might have one that is less kilometers, but because the range is closer, the angular separation might be a little bit more. If I click on, let's see here, so here we have a satellite and a piece of debris. So you see we have no orbital data there because this file that we downloaded is only active satellites. But here's my next possible conjunction. If I'm connected to my mount, I can then click slew to conjunction point, and I can't because it's actually below the site limits. Let's try that one. Okay, so my telescope is going to slew to the point of conjunction. it turns green, that means it's arrived. And so it's just going to sit there and wait. So in this case, we have over half an hour yet before the satellite, but we'll see the satellite path come across here, and then you'll see the little blue dot of the satellite approaching, and when it comes into the circle, that's the time of the conjunction. So it's fairly easy to use. I'm going to show a few videos that I took when I was testing this out. I haven't had a lot of time to test it out. I've had a lot of clouds here, but it's almost scary watching how close those satellites come to each other. As we know, there's an ever-growing number of satellites being launched into orbit, and unfortunately there's ever-growing amount of debris, and this kind of conjunction analysis is becoming more and more relevant in others. As noted on SOCRATES Plus webpage, they offer that service, hoping that it's going to assist satellite operators in avoiding these close approaches. As a satellite, as a SkyTrack user, I'm hoping that by viewing, recording, and possibly sharing some of these videos of near misses, that we can help raise awareness also of this critical issue. I encourage you to do some searching on something called Kessler syndrome. Kessler syndrome describes a sequence of events where there is a satellite collision which creates more debris, which could in turn cause more collisions until you get this cascading chain reaction, or this runaway event where almost all satellites would end up being destroyed, colliding with one another and debris. And if that ever happened, you can only imagine how catastrophic that would be. And it's estimated if it did happen, it could take up to 50 years to clean up all that debris, if you can imagine that. So I hope you enjoy this new SkyTrack feature, and I really encourage you to go to the Celestrak page and consider donating. Celestrak is a non-profit service, a very valuable service, and for us SkyTrack users, of course, it makes both orbital and now conjunction data freely available for our use. So to close off the video, I'm just going to show a few quick video clips of imaging I did using this new feature of near satellite collisions. Thanks for now.